Good day, viewers. This is 300 Plus Academy, where all we do is exams tutoring, ensuring that you ace your next exam. Still on the business of chemistry 2024 practical for Waec examination. I haven't looked at volumetric or titrometric analysis, and of course, looked at probable question. It's about time we look at what we call qualitative analysis, talking about identifying ions, anions, cations, gases in a given sample in the course of this exam, more popularly known as a salt analysis. So this year, we are going to be given a certain sample tagged C. Yes, in this case Cn, where n is going to be the number of the respective candidates. So say I am writing this exam and I am candidate number 30. That means my sample very likely will be labeled C30. So I'm going to be given a sample Cn labeled, and I need you to know that this particular sample is a mixture of two inorganic salts. Talking about these two inorganic salts, we are looking at lead triazonitrate 5 and of course sodium triazocarbonate 4. Now, looking at these two salts, although you are not going to be told this is the business of your instructors, there is a certain reaction that is going to happen here. Now, the state of this, when we dissolve this in water and we dissolve this in water, that's in aqueous form. Now, we're going to be given the solid sample. So let's say, okay, this is a solid sample. You're going to have to dissolve this, in water. If we put the sample here, you're then going to have to dissolve, add distilled water. Of course, when you add distilled water, okay, let this get to this level, and then you're going to be instructed to shake this thoroughly. When you do this, so you're going to have, it's more like now having the lead triazonitrate 5 in aqueous or solution form, and sodium carbonate as well in solution form. So that what will happen here is what we call double displacement reaction. Yeah, double displacement reaction. And in this case, given lead triazonitrate 5 actually is soluble on its own. Sodium carbonate naturally on its own in water is a soluble salt, and that's why we have aqueous, they are in solution form. But this is what the product will be. Sodium is capable of actually displacing lead here, given that sodium is a stronger reducing agent. It is higher up in the electrochemical series. So sodium has the tendency to displace lead from this given mixture setup here. So what we're going to have is 2 moles of sodium triazonitrate 5. And sodium, all triazonitrate, like they are soluble. So this is still soluble. In fact, this is going to be something like our filtrate. This will be our filtrate, as I'll soon show us. And then you're going to have lead combining with carbonate. So in this case, you have plus lead triazocarbonate 4. You see this lead triazocarbonate 4. We all know that all triazocarbonate 4 are not soluble except for the carbonate of sodium and potassium. So lead carbonate is insoluble, and this here is going to form our residue. Just like when in this case, you're going to be told this is the mixture you're going to have. So you will be instructed to filter this. Now, let's say this is our filter paper. Let's say this is our filter paper. If you take these two solutions and you pour here, you need to understand that this sodium triazonitrate 5 is in solution form, and that is going to form your it's going to pass through the pores of the filter paper, and then you're going to have sodium triazonitrate 5 here, and this here is going to be your filtrate. But the lead triazocarbonate 4 is going to remain on the filter paper as your residue. It's going to remain as your residue. In this case, this filtrate is going to be colorless. It's going to be colorless, just like the color of water. But in the case of the residue, you're looking at the white residue remaining on the paper. So when we say CN for your exam this year, CN is actually a combination of these, and this is a combination of lead nitrate and sodium carbonate, out of which you are going to have a solution that's a colorless filtrate, where we are going to have the insoluble portion talking about lead carbonate, and that is going to form the residue. So the next thing you're going to see coming up on your screen is going to be some set of questions which is at least going to be not less than 80% of what you're going to get in this exam. Emphasis on the word exact question that you're going to get as it relates to sample CN. So moving on, what exactly is your question going to look like in this exam? As you can see popping up on your screen, it says C is a mixture of two inorganic compounds. Carry out the following exercises on C. Record your observation, identify any gases evolved, state the conclusions you draw from your result for each test. Now, look at question 1. It says, put all of C in a boiling tube and add about 10 cm cube of distilled water, shake thoroughly, and filter. Keep both the residue and the filtrate. That's exactly what I was talking about. So you're just going to be given a sample CN, and then you're going to be asked to perform question 1. So how are you going to record that? Of course, you're going to have your test, your observation, and then the inferences you're going to draw. Now, let's assume I'm candidate number 30, and my sample has been labeled CN. So what I'm going to have here is C30 plus H2O, then filtered. That's exactly the instruction I was given for question 1. Put all of C in a boiling tube and add about 10 cm cube of distilled water, shake thoroughly, and filter. Of course, when you put C, when you add water into C and you shake together vigorously, it is going to partly dissolve. Some of the salt will dissolve, while some of the salt components will not dissolve, irrespective of how vigorously you shake that in your boiling tube or your test tube. So how you are going to record your observation is this, that the CN in question here partly dissolves, which means it does not dissolve completely, partly dissolves. And then when something partly dissolves, you have to tell us the color of what are dissolved, that's what forms the filtrates, and you have to tell us the color of the residue that will remain on the filter paper. So in this case, you're going to have a colorless filtrate, just like the color of water, colorless, and then you're going to have a white residue on the filter paper, in which case you have carried out the test, you've been able to record your observation using the right words. Also, you have to talk about your inference or conclusion. So my conclusion here for question 1 is going to be that I have soluble and insoluble salt. That is why some part of the salt dissolved and some part did not dissolve. So I'll say soluble and insoluble salts. Yes, that is my inference for the first question. So to the next question, as you can see on your screen, it says to about 2 cm cube of the filtrate. So it means that for question 2, we're about to work on the filtrate. So when you see a question talking about the filtrate, the aim will be to try to identify the anion here that's talking about NO3 minus. So as you can see for the question 2, it says to about 2 cm cube of the filtrate, add few drops of freshly prepared iron sulfate, that's iron 2 tetrahydral sulfate, and followed by conc sulfuric acid, that's H2SO4. Of course, you're going to record your test like filtrate plus FeSO4 plus conc H2SO4. When you do that, what is going to be your observation? As you can see on your screen, you're going to see a brown ring formed between the layer, between the junction of the acid. So first you have the filtrate, you're going to add iron sulfate to the filtrate. There you have a certain aqueous solution there. Then by the time you add your H2SO4, between the junction of the H2SO4 and the aqueous solution in the test tube meeting, a brown ring is going to be formed, which here we call the brown ring test. Look at it. Brown ring is formed at the junction of the acid and aqueous solution, or you simply put it as a brown ring observed between two liquid layer. This is what we call the brown ring test. And what you're going to infer in this situation is going to be triazole 5 ion NO3 minus confirmed. This is not suspected but confirmed. It is NO3 that gives a brown ring when these reagents are being used. So that ends question 2. It's just about being precise when it comes to chemistry. There is no room for guessing or not doing things the right way. You just have to be precise, and I can tell you that this is very likely your question as far as a sample C which you're going to get for your exam is concerned. Okay, moving on to the next question, question 3. As you can see on your screen, it says put the residue. So we're about to talk about the residue now, talking about lead triazocarbonate for the insoluble components here. It says put the residue in a test tube and then add about 2 cm cube of dilute acid. Most times when you add acid to a solid substance or a residue which is a solid as well, an insoluble solid in this case, you are very likely to have gases being liberated. So in this case, to your residue, that's what is on the filter paper. To your residue, when you add dilute hydrochloric acid, what you're going to have is a colorless, odorless gas will be evolved, which turns blue litmus red. The fact that the gas that will be evolved is going to turn blue litmus red tells me that this here is an acidic gas. Acidic gas. And then talking about the confirmatory test for that particular gas, that gas has the ability to turn lime water milky. In this case, that is going to be CO2 gas. CO2 gas. CO2 gas. So when you say CO2 gas, it's going to be from CO3 2 minus. So CO3 2 minus, that's triazocarbonate ion confirmed. There, look at it very well. Residue plus dilute HCl. Yes, depending on how you see things, effervescence might occur here. Effervescence. Okay, so you may want to add that to this, that okay, effervescence occurs and a colorless, odorless gas, effervescence effervescence. So I think you should put that first. Effervescence occurs and a colorless, odorless gas evolved. That's talking about effervescence here. You're going to see, maybe you had the acid touches the residue, you're going to see bubbles. Okay, so we see we call that bubbles effervescence. You see effervescence occurs and a colorless, odorless gas is evolved, and this gas here turns blue litmus red and turns lime water milky. That's the confirmatory test for CO2 gas from triazocarbonate 4 anion, and that ends question 3. So moving on to the next question, having looked at question 3, talking about adding dilute HCl to the residue. If you look at question 4, it says add aqueous ammonia solution, as add ammonia solution in drops to a portion of the mixture from 3. So which means we are going to be making use of the resulting mixture from 3. That's the residue that have been dissolved by the HCl. So we're going to take a portion of the mixture that we have from question 3, and we're going to use that for question 4. It says add ammonia solution in drops to a portion of the mixture from 3 and then in excess. So that means the residue plus HCl plus ammonia, now ammonia solution in drops and then in excess. You see, when you add ammonia, aqueous ammonia to this mixture here, what you're going to have is a white jelly-like precipitate. We call that white gelatinous precipitate. When I say gelatinous here, I mean more like a pap smear. Jelly-like precipitate is going to be in that mixture that will not dissolve. Look and see, the observation here is going to be a white gelatinous precipitate, which when we add excess ammonia now is not going to dissolve. It is insoluble. White gelatinous precipitate, insoluble in excess. So in this regard, if we were using sodium hydroxide, for example, we are going to have white precipitate, and that particular precipitate will be insoluble in the case of lead, in the case of aluminum, and in the case of zinc. But in the case of ammonia, that's if we were to use sodium hydroxide here, if we had used sodium hydroxide, we would have had a white precipitate which will be insoluble in excess, and for our inference we would have suspected lead ion Pb2 plus, aluminum ion Al3 plus, and the zinc ion Zn2 plus. These are the 3 ions we would have suspected. But in the case of ammonia, for zinc, the precipitate is going to be soluble. The precipitate will dissolve in excess ammonia. So in this case, zinc is off. So what we have here as our inference is that lead or aluminum ion suspected, because with aqueous ammonia, it is lead and aluminum that will form a white precipitate which will not dissolve in excess aqueous ammonia. But in the case of zinc, the precipitate would have dissolved. That is why we cannot suspect zinc here. And that ends that question 4. Now to the last question, as you can see on your screen. It says to a portion of the mixture in 3. So which means we are the solution we have for 3, we are meant to portion it into about 2 different test tubes. So we've used one for question 4. We'll be using the last one for question 5. It says, as you can see in that question, to a portion of the mixture in 3, add K2Cr2O7, that potassium heptaozo dichromate 6, K2Cr2O7, or potassium iodide. Any of them can be used in this case. So either you have potassium heptaozo dichromate 6 or potassium iodide, you're still going to get the same result here. So residue plus dilute HCl, which we have for question 3. If we add acidified potassium heptaozo dichromate 6 here, as you can see on your screen, you're going to have a heavy yellow precipitate. Yes, heavy yellow precipitate. Either you are using potassium heptazodichromate 7 or you're using potassium iodide. Any of them, if you're told to use any of them, you're going to have a heavy yellow precipitate, and in that case, that is the confirmatory test for lead. So you say here lead Pb2 plus confirmed. And that's just about all you're going to have for your Waec chemistry practical exam. Don't forget, this is where you need to be to ace your next exam. Biology practical coming your way, physics practical as well coming your way. Share with your peers, and don't forget, hit the subscribe button. Thank you for all of your comments. If you have any question, don't hesitate to comment. We will attend to your every question. From myself and the entire team at 300 plus, it is bye for now.